Bismillahirrahmanirrahim. Hi everyone, Assalamualaikum. Okay, today we're going to continue our topic on the reinforced concrete column. Okay, so hari ini kita akan belajar berkenaan dengan design on RC column. Okay, so biasa at the end of this topic, students should able to first, we must be able to describe the types of column. Okay, how to identify whether the short or long column, and also to design the short brace column. So this is the determination of this topic or this chapter. Okay. Okay, for the introduction, apa itu column sebenarnya? Okay, column itu sebenarnya adalah tiang. Okay. And the function of column is to act as the vertical load carrying member. Load are primarily compressive, although the situation do arise from the moment are also present. Okay, so column are classified as ada 4 jenis: short brace, short arm brace, slender brace, slender arm brace. Okay, this detail saya akan terangkan nanti. Tapi apa yang you guys tahu adalah bila short tu maksudnya dia pendek lah. Bila slender tu maksudnya dia akan dipanjang. Okay. And most of the time is column ini dia akan bawa load type of compression. Okay. Most of the time memang compression yang dia akan bawa. Okay. So tension is never and moment is sometimes. So kita dah tahu column ni adalah tiang. Okay. Tiang yang menghubungkan yang membawa load-load daripada atas. So maksudnya daripada sebelum ni kita dah belajar design of slab, design of beam. So design of slab akan pergi ke design akan mempengaruhi design of beam. So dapat dekat tiang pula akan dipengaruhi oleh design of beam. Maksudnya nanti load itu akan dibawa last kali dia akan pergi ke column dan seterusnya akan pergi ke foundation. Okay. So sekarang kita nak design column pula. Okay. So this is macam mana dia nak exact types. So tadi ada 4 jenis. So kita nak verify dia tu depends on the beberapa factor. Ada geometry, factor affecting and restraint. So you guys boleh baca kat sini apa yang menyebabkan dia punya types of columns tu. Okay. So columns ni, there are variety of columns. Boleh jadi dalam bentuk square, rectangular, circular, elliptical, cruciform or other shapes. Okay. So tapi normally yang kita biasa guna adalah this type of column lah. Square and also the circular, the rectangular. Okay. And the initial dimensional are normally determined by taking into account the required for durability and fire resistance. Okay, before this kita dah belajar dah. Untuk durability and fire resistance dia ada dia punya allowable. Maksudnya dia kata dia punya allowable cover berapa yang dia nak. So kita akan refer table 3.3 dan 3.4, 3.3 and 3.4. And it is not practical to cast vertical column smaller than 200 times 200 mm. Okay. So maksudnya kalau secara praktikalnya tidak boleh untuk kita design the vertical column lebih kecil daripada 200 kali 200. Okay. So apa itu braces and unbraces column? Okay. So reinforced column are classified as either braces or unbraces. Okay. So the different related to the manner which the structures carries the lateral load. Okay, saya tunjuk satu-satu. Okay, this is for the brace column. So brace column maksudnya dia ada bila lateral load are transmitted to the down to the foundation through the bracing and the shear wall. Okay, bracing ni adalah kita punya shear wall lah. Okay, bracing or shear wall. So maksudnya the lateral load ni dia transmit, dia nak alihkan the lateral load kepada foundation melalui bracing ataupun shear wall. Okay. For the unbraced frame, the lateral load are transmitted down to the foundation by the interaction between beam and columns. Okay, so maksudnya kat sini dia tak ada pun shear wall, dia tak ada bracing. So dia terus je direct lateral load tu adalah dialihkan, ditransfer ke foundation dengan cara interaction between beam and column. Itu beza antara braces and unbraced column. Okay. The column is said to be braced if the shear wall or other bracing used to cope with the lateral loads due to the wind. Okay, for this example, this lah. Kita ada shear wall untuk resist the wind load or the lateral load. Okay. Okay. The column is unbraced if lateral load are carried by sway action of column as shown in this various flow plan. Okay. So kalau kat sini maksudnya column unbraced in both direction. Maksudnya tak ada apa-apa wall kat sini. Okay. Ni column braced in 4 direction. Dia tunjuk contoh kepada ada shear wall dekat sini. Okay. Column braced in Y direction and unbraced in X direction. Okay, and in this module, we only focus on the brace column. We only consider only on the brace column. Okay. Okay. Column has to be classified because of their different failure mode and design consideration. But the typical failure of the column is like this. Okay, maksudnya kita akan nampak failnya dekat column itu normally mode dia lebih kurang macam ni lah. Akan ada crack due to the compression. So kita ada load dekat atas, dia akan compress kan. So kat sini akan ada failure. Okay, so that's why we need to design the RC, the required RC, required reinforce untuk overcome the failure. Okay. So possible failure mechanism can be categorized. Satu, material failure with the negligible lateral deflection usually occur in the short column. Material failure intensified by lateral deflection and additional moment. Ni typical dia adalah intermediate column. Okay, instability failure. So the material ni ada instability failure which occur with the slender column and liable to be preceded by excessive deflection. And according to Eurocode, column boleh jadi short or slender depending on the ratio of their effective height to their lateral dimension. So, apa effective height ni? Ada setengah term disebut effective height. Ada setengah itu disebut effective length. Tapi dua-dua adalah LO. Okay? Ini sepatutnya rapat ni. Sekalikan. So, effective height can be found by multiplying the column clear height by a factor from table 9.1. Okay? Which depends on the degree of fixity of the top and bottom of the column. Figure 9.7. Okay, so banyak benda kita nak refer. Apa yang first sekali adalah, dia adalah darab daripada clear column kepada factor. Okay. Clear column ni, macam mana kita nak tahu clear column ini adalah daripada bawah beam ke atas foundation. Ataupun ni bawah beam ke atas slab. Okay. So, clear height adalah tak ada beam, tak ada slab. Dia adalah ruang kosong ini. Kalau ini, dia di antara foundation dan juga beam. Okay, so itu adalah clear height. Tapi effective height adalah column clear height times with the factor. Okay. Nanti saya tunjuk faktor 9.1. Okay. Depends on the degree of fixity. Maksudnya nak tengok pula degree of fixity ni dekat top and bottom. Maksudnya let's say kita nak design column ni, kita kena tengok dekat atas ni keadaan ni macam mana, dekat bawah ni keadaan ni macam mana. Okay. And okay, kita dah kira dia punya effective height. Okay. So the reinforced concrete column are classified as slender if their slenderness ratio, okay, is greater than the limiting value. Okay. So maksud nak cakap kat sini, ini adalah dia punya limiting value yang dibenarkan. Okay. So we need to calculate the slenderness ratio. Okay. This slender if their slenderness ratio is greater than the limiting ratio. So kita nak kena kira dia punya limiting value lah. Comparekan. Okay. This is the equation. Apa itu A, apa itu B, apa itu C adalah constant. Depends on the types of the column. Okay. So kita nak study pasal brace column. So dia ada value-value dia kat sini. Okay. Yang tadi effective height factors for brace column L0 ataupun L0, clear height, yang tadi kita dah tahu clear height tu tak ada slab, tak ada beam, tak ada foundation, it's clear height times with the factor from this table. Okay, so kita kena darabkanlah dengan factor bergantung kepada keadaan dia. Okay, and condition at tops and condition at bottom. Apa itu condition 1, apa itu condition 2, apa itu condition 3. Kita boleh refer dekat sini. Okay. Ataupun lebih jelas dekat figure ni. Condition 1, bila mana depth of the beam lebih besar atau sama dengan depth of the column. Okay. Condition 2, depth of the beam or slab is less than depth of the column. And condition 3 adalah nominal restraint between beam and column. Example, beam design and details as a simply supported. Base are not designed to resist the moment. So, dia depends on the end fixity condition. Nak nilai dia tu, berapa nilainya. Let's say, dalam keadaan yang pertama, dia punya beam adalah lebih besar atau sama dengan depth of the column. So, dia akan ambil value 0.75. Okay. So, for a rectangular section, radius gradation, okay. So, the limiting ratio adalah, dia tengok yang ujung ni lah. Dia dah substitute, ini nilainya. Okay. So, kita nak pakai sekarang for the brace column, the parameter A, B, C dah diberi. So, you just substitute the A, B, C value in this equation in order to find the limiting LO divided by B ratio. So, this is the final equation for the limiting L0 divided by B ratio. Okay. So, the actual L0 B ratio is not more than the limiting value, then the column is short, not slender. Kira maksudnya, kita akan kira the actual value of L0 divided by B, then compare with the limiting L0 divided by B ratio. So, if the value is less than the limiting value, so the column is short. If the actual L0 divided by B is more than limiting value, so it will become the slender column. So in practice, most of the reinforced column are short and not slender, and this module will not cover the design of the slender column. Okay, I think that's all for this. I stop with the first part, then I will continue with the second part of this chapter. Alright, thank you. Assalamualaikum.